Okay, so what I'm going to do with this video is really just review what we, at least for second period, what we did going through this review sort of step by step. So what should we be able to do? First section, numeric, algebraic, graphical models. Second section, all those things that deal with functions. Domain, range, continuous, increasing, decreasing, extrema. Third section, 12 basic functions. You need to know things about certain functions. So first of all, the question I had gone over is with the first section, answer questions about a graphical, numerical, or algebraic model. So if I say that the price of cereal started in 2000 at $1.50 and it's gone up 8 cents after that. This is the algebraic model. If I say x is since 2000, x equals 0 has to be 2000. So if I said to graph that, well, you could find some points starting at 2000, which would be 0, plug in 0, plug in 1, plug in 2. Obviously, that's a linear function, y equals mx plus b. If I asked a question like, what's the price in 2019? Since x is years, 2019, I would plug in 19 for x, plug it in, $3.02. So, this is algebraic. Your little dots that you found are numerical, and the graphical is the picture of the graph. Quadratic equations, algebraically, quadratic formula, factor, or complete the square. So I gave this question. Well, I notice it says algebraically, that's a quadratic. Those big numbers, I'm going to do the quadratic formula. So I bring everything over. I subtracted 328. I do the opposite of b, plus or minus. I mean, where this thing came from, b squared minus 4 times 25 times negative 328. Now, if I asked you to give me a decimal approximation, you do negative 12 plus the square root of 32,944, press equals, divide by 50. So I get 3.39. I do the same thing, but instead of adding, I do negative 12 minus that square root divided by 50, and I get negative 3.87. Algebraically means I showed that work. So I need to be able to do a quadratic. Then this one was where I had a radical. So, you think of the original question, which was 2x minus 3 equals the square root of x plus 4. I squared both sides to get rid of that radical. When I squared the right, I got x plus 4. But when I square the left, I've got to do 2x minus 3 times 2x minus 3. Once I got to here, I have a quadratic. So I'm going to solve bringing everything over. So I subtracted x, subtracted 4. There's my quadratic. Do the formula. Remember here, if you're someone who's putting negative 13, you better put squared, parentheses. I just don't do that. This is what you should have gotten. You do those two. You're going to have to do decimals if it doesn't factor. So we did the decimals. We got 0.5, 2.8. You go back and check it. Why would 0.5 not work? If you do 2 times 0.5 minus 3, you get, that's going to give you 1 minus 3 is negative 2. That is not equal to the square root of 0.5 plus 4. So that's why I crossed it off. So find domain, answer in interval notation. So with the first one that I did, x plus the square root of 3 minus x. If I have a radical and it's not in a fraction, I set it greater than or equal to 0. So from there, I got x is less than or equal to 3. If you think of a line, that means all that stuff. How does all that stuff get written in interval notation? The only x's that will work are the ones below 3 and including 3. With the second one I gave, I have a fraction. The bottom can equal 0. The top has a radical. Now, if it didn't have a radical, I would leave it alone. But it has a radical. So, greater than or equal to 0, I get this and I get this. Well, if I think of a number line, greater than or equal to negative 6 is all that stuff. But when I get to 1, it can't be 1. But then it's everything after that. So it starts at negative 6. It goes to 1. It can't be 1. So 1 is in both of those parentheses to infinity. Range. We think with range, we graph it. So we're looking at that graph. You guys put this in Desmos. I put it in a graphing calculator. If I think and I look at this picture, don't think about domain. This is range. When I look at this picture, I need low to high. When I'm looking low to high, there's no y's until I get there. And so they start there. Desmos, it's probably even easier to see, and then it goes up. So just looking at that picture, most common wrong answer here is people will say 2 to infinity. That is the domain. I want the range. Graph it. Vertical and horizontal asymptotes of a function. Remember, you put it in your calculator. You sort of think, hey, do I have any gaps? Do I have things that it's getting closer and closer to? You look and you should be able to say, hey, it's got some vertical. Vertical lines are x equals. How do you find those vertical asymptotes? Set the bottom equal to 0. If you solved that, you would add 1, you would square root it, and that's where I got plus or minus 1. With horizontal, what am I going to do for those horizontal? I'm going to put, if I'm a Desmos person, I'm going to hit that little table thing, and I'm going to go to a big X or a really small X. What are my Y's in that table getting closer to? Because that doesn't have to be some of you would put 0. That is not getting closer and closer to 0. That is getting closer and closer to 1. Use Desmos and use that table feature. State where a function is increasing or decreasing, extrema, symmetry, bound. So these would be, I can do anything that I ask about this. So I put it in my calculator. I could also ask zeros, you know. I find extrema, zeros, whatever's needed. So this comes out negative 0.5, negative 1. So when I say, you know, what are some things that I could ask? Where is it increasing? So I look left to right. It's decreasing from negative infinity. I use x's to negative 0.5. Then my graph is going up. So it's increasing from negative 0.5 to infinity. If I said extrema, that is a min of y equals negative 1 at x equals negative 0.5. If I said boundedness, that is bounded below because it has a min that is absolute. End behavior, as always, x goes to infinity. Where's f of x going? This is to the right. Well, if I look to the right, my graph's going up, which is infinity. If I look to the left, my graph is also going up, which is infinity. So that's end behavior. Boundedness. The other thing is symmetry. Some of you might say this is even, but if it was even, the minimum would be on the y-axis. This is not even or odd because it's shifted over a little bit, so it would be neither. If I gave you the next one, same questions. You know, I'm just going to make these points up because I don't know them. 0.5, let's say negative 1. It's not what they are. Negative 0.5, positive 1. So things I could say. Increasing, decreasing, left to right. It's increasing from always negative infinity unless it doesn't start to the left. When does it stop? At that x. Then it goes down. So it's decreasing from negative 0.5 to 0.5. Then it goes up. So I would go back here, increasing from 0.5 to infinity. Extrema, max of y equals 1 at x equals negative 0.5. Min of y equals negative 1 at x equals positive 0.5. This is not bounded because it's going to infinity to the right and negative infinity to the left. It does not have an absolute max or min. I would say as x goes to infinity, as you look to the right, your graph is going up. As you look to the left, your graph is going down, negative infinity. Symmetry, well, if you look at these points, just look at them. The x's are opposite, the y's are opposite. So that's origin. It is odd, but how do you prove that? So you have to know that odd means f of negative x is the opposite of f of x. So f of negative x means I am putting a negative x in that function. So I would have 2 times negative x cubed minus 3 times negative x. On the right, that would be the left. On the right, negative f of x is that. Well, the right is easy. Just distribute. That's what you would get. On the left, what happens? Well, if you cube a negative, you get a negative. So that is going to be negative 2x cubed. If you take negative 3x times negative x, that's going to be positive 3x. The left side equals the right side. You're good. This last one, same idea. Absolute value of 3x added to negative 2x. You find that that min is 0, 0. Same things, I could say decreasing from negative infinity to 0. Then it's going up from 0 to infinity, but I'm using that. Extrema, a min of y equals 0 at x equals 0. It is bounded below because it has an absolute min. Symmetry, it is not even or odd. That does not flip and look the same on both sides. End behavior, as I look to the right, my graph is going up. As I look to the left, my graph is going up. I think that's everything that's asked. So hopefully you can answer those questions. Knowledge of the 12 basic functions, the last thing. You know, if I say, what are things that have a domain negative infinity to infinity? Absolute value, a line, a cube, a quadratic. You know, you can think of anything that has arrows to the left and arrows to the right. Even, which functions are even? You want to think that absolute value and the quadratic always go together. I mean, it's a u and a v. Whatever they have, they're the same. The other big even function, you want to know those trig functions. Cosine is even. Odd, sine is even. Now, what should you know also goes together? A line, which is the identity function, and the cubic. I mean, a cubic, x cubed is really just a curved line. They do the same thing. The other odd one is the inverse, which is your one with the two asymptotes. Bounded, you know, what are the most famous bounded functions? Cosine, sine, they're between two lines, but you should also know that logistic is bounded because it's sort of like that Egyptian. Continuous, anything that doesn't have an asymptote. You know, what's not continuous? The inverse and the step function. So you have to look those over, know certain things. You have to either give me the equation or the name. So look this stuff over. Be ready for that quiz.